I'm gonna try recording this. So yeah, let me do that again. So, welcome to the first stream. Today we're building a Anaglyph 3D rendering engine. If you don't know what Anaglyph 3D is, it's the sort of red and blue 3D glasses sort of stuff. So that's pretty exciting. I've built one of these already, but I just wanted to build one on stream. So, yeah. I think this thing is ducking a bit too much. Hang on. Oh shoot, I was supposed to go filters. Let's turn that down. Well, I guess that'll work. Maybe turn the... yeah, that's a bit better. But yeah. Let's cut to the screen. As you see, we have an entirely blank project window. We are starting this from scratch, and we're doing this all in Turbo Warp. I'm going to switch this to 19 by... or 16 by 9. Because I like that. We're not doing 60 FPS or interpolation, because I think I'm tight on computer resources. Store settings of project. I'm going to go ahead and save this. There we go. And we're not doing any polygons or anything, we're just building a simple sort of renderer to like do two-dimensional sprites. So if you have any 3D glasses or anything, please put those on. That's gonna be very tremendously handy for you. I'm gonna whip together a couple of variables. IPD, if you don't know what IPD is, it's interpupillary distance or something. And last I checked, that's just the distance between your eyes. Which is very handy in seeing multiple things, because if you close one eye and then close the other, you see that all the objects look slightly shifted to the left or right, depending on where you are. Now, focal length. I can't explain this. Basically, how extreme moving forward and backward is for objects. It's easier to show you with a actual, like, polygon rendered 3D scene, but, yeah, I'll explain it in the future. We're gonna set this to 360 for now, because that worked well for me last time, so it'll probably work well for me this time. Now, iHash, this is just like which eye you'll be rendering, of course. Let's see here, I think that is all the variables I need. I'll keep my variable around just in case. Let's see here. Project to X, Y, Z, X, Y, and Z. And with some IPD, 1 second. Oh, is my desktop audio on? It's not. We don't need it. Okay. Sorry, I'm just messing around with some references, because I'm not gonna remember all the math stuff, because there's some extra special math. Oh shoot. But yeah. Like, I remember most of the math, just there's some doohickey math or whatever that makes it a little more difficult. Okay, project to XYZ. Projecting, in this case, is basically turning a set of 3D coordinates into 2D coordinates that could be rendered onto your screen. Stuff like that. That should be 3. Hang on, I messed that up. Yeah. IPD. Should I also include something for the focal length? I think I should, because that could be a fun effect. In fact, if this one works well enough, I might just replace the one I've been working on with this. But yeah, we're gonna start with set I to 1, and then we're gonna set I to I plus 1 modulo 2. If I show that, set I to 1, oh, it's 0, oh, it's 1, oh, it's 0. That's pretty handy to have, in my opinion. And I believe my opinion is correct. P2, oh, yeah. Let me get my 3D glasses onto my head real quick. Okay, they're on my head. Now, wait a second. Okay. Okay, I know, I remember now. Render. Render goes here. Now, let me show you the reason why we have an I number variable. So of course you're going to want to add the IPD here, but what happens when you add the same value to both eyes? Both your eyes see the same thing, so we got to add 1 to the eye and subtract the same from the other eye. So what we are going to do is subtract the eye so that's 1, and then if we do this, it should be -1. Yay, it worked. And then we're going to multiply that so that we have our IPD. What on earth? I ain't never seen a -0 before. That's interesting to see. I'm surprised I haven't exploded my computer yet. Anyways, so now we have this IPD sort of stuff implemented. Focal, I'll put the focal length in there. My brother's Bluetooth speaker is doing things. Give me a second, I'm gonna turn it off. I'm back. It turns out the thing it was doing was turning itself off, so that's nice. So, Y0, X, we're gonna put that to mouse X, so we could jiggle around and see that. Z, which is forward and backwards, not up and down, instead of connecting this to Y, we're going to add 180 to it, so that down here, you see how the second here is negative 180. So the lowest it can go is 0, because 0 and negative z values are not something you should ever see. So, yeah. Now that's most of the render sprite setup. Hang on, I need to add a couple extensions. Now, since we're doing Anaglyph 3D, we need to see, we need to see the red and green channels. Red, green, and blue channels separately. I can never get it right on my first time. Actually, let's see what happens when I switch these around. Okay. Okay. Because, yeah, you want to subtract from the left eye and add it to the right eye, because your left eye is further to the left than the right eye, and left is less than right in this case. And so in this case, we should, once we get this projector math set up, we should see cyan on the left and red on the right, since it's going to be popping out of the screen. Speaking of that, we're going to go ahead and work on that. So all projection is taking x and y and dividing them both by z, and then multiplying the end result of that by our lovely focal length. I'm going to finish setting up this renderer because I actually forgot to. You all should be on. Oh, hi! Hey! I'm sorry, I was not looking at chat. Hey, it's not too complicated. It's just math right now. But yeah, if we do this, we will see that nothing happens, because I forgot to actually build anything that runs the code. Now, it should work. I think it works. I just forgot also with pre-rendered sprites, we also need to scale the size along with it. So now it should be getting farther away, closer, closer. It's close. I forgot. I also need to remove fencing and the miscellaneous limits, because I'm too lazy to do any workarounds for that. And now you see it basically looks like it's moving around in 3D space. Now, we're going to start the fun part of adding the